Good afternoon, everyone, and thank you for joining with us. Let's go and get ready to welcome Agrawal, Managing Director of Minimac System Private Limited, to tell us more about circular economy and ESG in used lubricants and sectors. Welcome, Anshu.
Thank you so much. Thank you so much, Anas. It's nice to be back here at LRVS session on lubricants, reliability, and the various services, new concepts, technology around lubrication. And we have attended LRVS at multiple other editions in past, and I must say it's a great initiative for confluencing various ideas, technocrats, and people who are working in this field. Now, today I have a topic which is quite interesting and one of the most important ones when it comes to lubrication. Lubricants, as we all know, have a very strong impact on waste generation, and thereby a very aggressive approach is being taken by a lot of governments, industries, and agencies around the globe in order to curtail the production of lubricants as much as possible in order to maximize the efficiency of the lubricants and at the same time reduce the generation of used waste lubricants. Because there is a thumb rule that every drop of lubricant, when it is produced at the lube blenders plants, a liter of lubricant, a liter of brand new lubricant would generate around 1 kilogram of CO2 emissions already into the atmosphere. At the same time, when used lubricants or waste lubricants are disposed of in an unorganized manner, rather they are used for incineration and landfills, these have a potential of generating around 10 to 11 kilograms of CO2 in the environment against every liter of used lubricant which goes in an unorganized way disposal. So today I'll be talking with you on certain concepts on how the industrial space around the lubrication is presently standing and how the waste lubricants can be brought back into the circular economy and rather an organized sector. So let us first understand about the lubricants market. So I'll take an example from India where I belong to. The lubricants market stands at around $1.67 billion. It's the third largest lubricants market in the world. And India actually demands around 6% of the world's total lubricants produced. The overall concept of industrial lubricants constitutes to around 40% of the total lubricant which is being produced and consumed in the market. And out of this 40%, if you see the pie of various industries, power sector, steel sector, cement, oil and gas, and mining, they take up the majority share of consuming the lubricants around them. And that's the reason why if we talk of any initiatives or solutions around lubricant efficiency and lubricant life cycle management, these are the sectors which we need to watch for. Today, the lubricant sector, even the lube manufacturers, the brands of lubricants, they have understood the concept of differentiating offering because lubricants have become somewhere like a commodity. And in order to have a differentiation in the market and a monopoly position or a leadership position, they need to go ahead with value-added services, lubricant life cycle management services, and overall a reliability-centered maintenance approach. For this, they have a very strong objective. Almost all the industrial sectors today, they have an objective of reducing the breakdowns in their machineries by 25%, because it is a known fact by all that the maintenance expenditure of an equipment, around 80% of it goes into the lubrication related aspects. And around 40% of the equipment failures, it's because of poor lubrication aspects. So there are three wings of lubrication reliability. The first one is lubricant selection, the second is lubrication handling, and the third one is analysis and contamination control. We talk about all of these concepts of GHG protocol. So there are three major scopes under the GHG protocol. This is a standard protocol which is applicable to all the industries across the globe. The scope 1 is the direct scope. The scope 2 is the indirect one. If you increase the efficiency of your plant, if you increase the resources, the fuel resources utilization in your plant, you are going to have a better scope 1 and scope 2 initiative. However, these do not constitute the majority portion of the total CO2 impact that a company can have into the environment. The major portion is actually the scope 3. The scope 3 on the upstream side and scope 3 on the downstream side, which are the indirect scopes. For example, on the downstream side, if we talk about the lubricants, there are certain scopes like the use of the salt products, the end of life treatment of the various salt products, and processing of the salt products. So if lubricant is considered as a product or a material, so what is the end use of the lubricant? What happens after its usage or your entire life cycle is over? Is it disposed? Is it incinerated? Or is it used for landfill? So what happens with the used lubricant? That is the point of contention out here. And this is the area of improvement where the companies need to work, because the used lubricants today have possess a hazard worth 1:10 ratio, 1:11 ratio. So any used lubricant, if disposed of in an unorganized manner, if it is not brought back into the supply chain, into the re-refining process, that lubricant possesses huge amount of emissions. In order to explain it, we have a short video which I would like to present to our audience.
Lubrication is vital for smooth machinery operation. It reduces friction, minimizes wear and tear, and extends the lifespan of equipment. But did you know that adopting lubrication lifecycle management is crucial for achieving a circular economy and a sustainable environment to reach net zero goals? Let's visualize the journey of lubricants from production to disposal and see how Minimac contributes to this cycle. Oil, in its raw form, is categorized as virgin oil. It goes through lube blending plants, where it becomes industrial oil. This oil is then transferred to oil storage yards using large tankers and barrels. The industrial oil is extensively used in machinery, enduring rigorous testing and wear and tear. As it nears the end of its useful life, it becomes used oil, which is collected and segregated in different oil storage tanks. Waste oil, a blend of various used oils, is stored in a separate tank. Unfortunately, a major bulk of waste oil is currently disposed of, generating hazardous waste and depleting the environment, whereas a very nominal amount of waste oil goes for re-refining. This practice contributes to the emission of carbon dioxide. Here's where Minimac Systems steps in to build a circular economy in a sustainable environment. Minimac proposes a mid-life treatment, which involves a recurring purification of oil used in the tanks over the years, reducing new oil requirements and hazardous waste generation in turn, increasing the drain interval and introducing the concept of nano-circularity. Minimac's second offering is the end-of-life treatment, providing used oil reconditioning solutions. This promotes the reuse of oil and is termed micro-circularity. Currently, the major percentage of waste oil is incinerated or disposed of as hazardous waste. Minimac's third offering is waste oil collection solutions, where the waste oil is transported to re-refining plants. It is converted into re-refined base oil, RRBO, to be used as a feedstock for oil producers, bypassing emissions and promoting macro-circularity with an aim to provide pilferage-proof collection solutions. By implementing these solutions, the feedstock contributes to reducing a significant amount of carbon dioxide emission emitted by the waste oil disposal. This comprehensive cycle helps us move towards net zero and a better, sustainable tomorrow.
Thank you so much. So now we would like to talk about the inverted pyramid of waste management. We all know that the waste management starts at reduce, reuse, and recycle. So here we would like to introduce the concept of reformation in the overall hierarchy of waste management. By reformation, we mean to say the overall usage of lubrication and lubricant products need to be replaced with a better procedure and a better practice, which is known as the total fluid management or lube management solutions. In order to reduce the generation of waste lubricants, as the animation suggested, we need to perform mid-life treatment of the lubricants. By mid-life treatment, we mean to say lubricants do catch contaminations. Lubricants do catch degraded products, because of which the lubricants tend to lose their properties and they are wasted or they are discarded from the process of application much before the designed life of the lubricants. And hence we propose to have mid-life treatments on a regular basis on the lubricants so that the lubricant properties can remain intact for the entire designed life for the lubricants. The third thing which we produce is reuse. A lot of lubricants get discarded from their application areas because of contamination, and there are certain solutions with us which we can recondition the lubricants following certain technologies in the in situ plant itself. Means wherever the lubricants are being discarded, waste lubricant is being generated at the same place. The lubricant can be reconditioned and brought to fit use back into service. And the fourth R is the recycle, wherein the waste lubricants can be segregated, they can be collected back and sent to the genuine authorized recyclers and re-refiners who can thereby re-refine the lubricant and send it back to the lube blending process by selling it off to the lube producers. So this impact of circular economy is well known and well beneficial for all the stakeholders in the entire ecosystem of lubrication. The first is the lube user, the factory owner, where the lubricants are being used for various applications. So of course, they have two major benefits. The first one is reduction in oil purchase, which will enable a better cost advantage to them. At the same time, it would add to the environmental benefits because when you do not purchase the lubricant, you do not have any scope 3 in the indirect emission norms. Second, the reduction in oil waste disposal. And when you have the lubricant life improved and enhanced, naturally the oil wastage will go down drastically. Thereby, your emissions against scope 3 on the downward side, on the downstream side, that also has a major impact. For a lube company dealer or sales partner, there are multiple benefits if they get into the business of lubricant services. The first one is value-added services for their offerings. They find better customer loyalties. They are having a better penetration in the customer premises because they can do a round-the-clock service with their customers. And of course, thereby they can create a differentiated offering for their customers rather than the customization or the commoditization which has happened right now. For the lube company, they can have a better step towards ESG compliance. Today, a lot of companies are pledging net zero over the certain number of years in future. However, the scope 3 is being discarded by many companies. So if certain applications of circular economy around lubricants can be implemented, I'm sure a lot of scope 3 benefits can be imparted to all the lube companies who are participating in certain programs. And of course, the Mother Earth, the environment around us, if we can reduce the production of oil, if we can reduce the production of used oil and waste oil being disposed into the environment, we can bring down a lot of carbon dioxide being emitted into the environment. There are certain case studies around what we have been doing. So I would take up a case study from a refinery project in Oman in Middle East, because I understand we have a lot of audience from the Middle East region today. So in Middle East, in a particular refinery, the project timelines got slipped because of improper flushing activity of the compressor, and this was having an impact of around $5 to $6 million for the user company. The second steel plant project in India, which was suffering a major turbine-driven blower failure after the commissioning, this was going to incur a major loss for them in terms of oil replacements as well as parts replacements. The overall impact of this project was around $10 million, going negative for the user industry. And the third case study is from a thermal power plant, again in India, where they lost multiple servo valves against the FRF EH control system. And this was accounting for around $3 million overall impact. Let me take you through some of the other case studies where the CO2e savings have been calculated by our team. So one of these studies is from a power plant where the overall cost of oil replacement was around 44 lakhs Indian rupees. The total downtime was around 1.05 crores because of the 15 hours downtime, which was pertaining to poor lubrication and poor parameters of the lubricant. And they were about to change the entire lubricant, the entire lube oil quantity was being disposed of. So our team chipped in and we recycled the lubricant out there back to its original properties, and thereby saving around 14,000 kilograms of CO2e, abatement of CO2e. The second case study is from another power plant, wherein the overall cost for oil replacement was around 21 lakhs of Indian rupees. But more than that, the overall impact of changing the oil on the environment was heavy, was huge, and it stood at around 15,000 kilograms of CO2e, because if the oil was replaced, if the oil was disposed of, the amount of CO2e calculated was around 15,000 kgs. So at this particular plant as well, when the oil was reconditioned, it was brought back to well in service, and this happened around 5 years ago, and since then, the plant is running with perfectly no issues. The third case study is from a turbine, which is a Chinese turbine of around, I think it was an Indian turbine, not the Chinese, my mistake. So an Indian turbine, which was having around 16,000 liters of the fire resistant fluid, which is costly. At the same time, it is hazardous because it is not biologically degradable. So this had a major impact on oil replacement because the oil cost was humongously high. You can say it was in the range of around $400,000. So $500,000 amount for the oil replacement, and around 0.8 gigagrams of CO2e, around 1 gigagrams of CO2e, which is a huge number. So this amount of oil change, this amount of CO2e impact was about to happen in this particular plant. When Minimac team chipped in, we resolved the problem by carrying out the necessary reconditioning of the oil. So after the completion of the activity, the oil was brought back to service. The need for replacement was completely eliminated, thereby saving around 1 gigagram of CO2e from this plant location. Another case study comes from a power plant of coal-based power plants, and here the NAS levels of the oil had shot up to around NAS 10. It was a shutdown activity, and the plant had planned to change or replace the entire oil, which would have accounted for around 0.2 gigagrams of CO2e emission because of the change of the entire 72 kiloliters of oil. And here the team of Minimac chipped in with their ultra fine filtration procedure and reconditioning of the oil, so that during shutdown, the oil could be brought back to its life. It could be tested, and once it was fit for use, the same oil was continued after the turnaround, after the shutdown, thereby saving huge amount for the customer and also saving around 0.2 gigagrams of possible CO2e emission into the environment. So this is one of the solutions which Minimac has recently implemented in India, where because of the heavy water ingress into the turbine was having a possible failure and the turbine was going for a shutdown. So for this reason, the entire water was gone into the turbine tank, and because of it, the lubrication was at threat. The Minimac team came in with their coalescer solution, and continuously the coalescer worked for around 6 months in this power plant before the planned maintenance was scheduled. And during this period, around 500 liters of water was drained on a weekly basis. And because of this, the shutdown was averted, and 3 cities were avoided from going into the darkness. So this is all from my side, short presentation, but I believe it would be good enough for sensitizing the audience on this topic of circular economy around lubrication practices. I would like to invite any questions from the audience. If you would like to chip in the QA box, that will be better for Anas to guide me through. Thank you so much for hearing me out so patiently. Over to you, Anas.
Thank you, Anshuman. Thank you. We have is that a request? It's not a question. Is a request. Someone is Carlos is asking for the source for the EQ source. Like in the beginning of the presentation, you mentioned something about the emissions and the percentage of the emissions.
Right. So there are a lot of global data available on global emission websites, wherein you can find out against every material which is being produced, what is the net amount of CO2e which can be considered for the calculation of life cycle assessment of a particular product, commodity, or material. So these data have been taken from global directories around emissions. Emissions for producing a new lubricant, emissions for disposal of a waste lubricant.
Right. I have a question here. It says, I find this highly interesting. So thank you. The question here is saying, I find this highly interesting. Is there any third-party reports or data from these case studies?
Right.
The one that you present.
Yeah. So what happens is all these case studies are taken into consideration for detailed analysis and an understanding around any carbon credit calculations. So when you want to commercialize any of these data, then you certainly need a third-party report for that. And the owner organization or the company who is going to present such kind of data or such kind of case studies, they need certainly go through the third-party evaluation of the entire project. However, for the internal purposes, whenever the companies report certain net zero initiatives or initiatives around ESG, such kind of reports and analysis are done in-house as well as by the third parties. And based on that, the reports are normally generated and they are reported in public forums. If we want to understand the third party, so every country has a lot of third parties who are working around ESG projects and projects which are calculating the life cycle assessment of a particular initiative or a particular act. Normally, these are economically feasible if they are done in a comprehensive manner rather than a small project manner. Because if you start doing it on a micro project basis, probably the costs of doing the analysis would be way too high. And hence, it is a company-wide initiative. So, for example, if there is a reporting company which is an aluminum producer and they are taking 10, 15, or 20 initiatives around ESG, around circular economy, around net zero, so they would be hiring a third-party consultant, and that consultant would take care of all the initiatives taken by them at one go and thereby produce a common report around that.
Thank you. More 2 questions I have. So if you don't mind, of course. Okay. How did you deal with filter elements disposal on ESG perspective?
Yeah,
that's a great
question. Yeah. That's a great question. Yeah. So yes, whenever we do carry out filtration, the first thing we keep in mind is to reduce the amount of consumables which are going to be incurred in a particular project. So the first thing we have to do is to minimize by having more of such filters which are non-disposable type, which are reusable type. So there are certain filters above certain micron ratings which are reusable, wherein they have a life as good as you can say infinity, because they do not go bad until and unless you have wear and tear onto the filter elements. However, we know everything, every stuff in this world has a life, and every material has a possible solution for recycling. So I can certainly say that whenever these filter elements get choked up, there is a solution for recycling these filter elements. Those need to be followed very tightly. And one very important fact here, whenever we take any initiative around reduction in CO2e emissions, we can never avoid 100%. If we take some initiative, every initiative would always cost certain amount of CO2e emission. And this is avoided or eliminated in terms of life cycle assessment calculations. So under a life cycle assessment calculation of any project, you would be accounting for all the negativity in the CO2e emission and all the positivity in the CO2e emissions by that particular project. And thereby you would account for the entire inventorization of the CO2e emissions through a particular initiative. And probably the suggestions or the initiatives that we are taking, they will always give you a positive impact over the GHG emission reduction.
Great. I have a question. It says, dear sir, waste oil recycle process, is it heavy? Does it have any health risks while using?
Yes.
Refining waste oil, for example, transformer oil, any PSPS will have safety risks.
By PSPS, can you help me? What does that mean?
I don't know, to be honest. So I'm reading.
Maybe it's the personal.
So the main question here is speaking about oil recycling process. Does it have any health risks while using this recycled oil, or while you're recycling that oil?
I understand. Yeah, maybe he's talking about the health risks and the pollution control board related safety norms. So here we are talking about recycling of the waste oil. And as far as we know, the processes and the technologies which are used under the recycling, they do not possess any health risks for the operators who are working around these plants. There might be certain safety norms which need to be implemented based on what safety norms are normally implemented in a lube blending plant or a plant where or a factory where the lubricants are produced. The similar norms and safety related compliances would be applicable for waste recycling as well.
Okay, thank you so much, Mr. Anshuman. That was for today. We really appreciate your participation. Thank you for being part of LRVS, and we look forward for next year.
Thank you so much, audience. Thank you so much, LRVS team, for inviting me. Have a great day ahead.
Thank you. Thank you all for participating, and have a good one. Bye.
Bye-bye.